Have you ever wondered how aluminum foil is made and what materials go into creating this everyday kitchen essential? In today's video, we're diving into the fascinating process of aluminum foil production. Aluminum foil is a staple in almost every kitchen, but the journey from raw material to the shiny, flexible sheets we use for cooking and food preservation is more complex than you might think. From mining bauxite to the advanced rolling techniques that give foil its signature thinness, we'll uncover how this versatile material is created. Stick with us to discover the detailed process that transforms raw minerals into the familiar aluminum foil we rely on daily. Before we get started, make sure to hit the like button if you're curious about the science behind everyday items, and don't forget to subscribe so you never miss out on our in-depth explorations. Let's get into it. How aluminum foil is made. Aluminum is one of the most versatile metals, combining the flexibility of paper with the strength of steel. It's widely used across many industries, particularly in the form of aluminum foil, which plays a crucial role in food preservation, cooking, and packaging. The journey from raw material to finished product begins with bauxite, a mineral found in tropical regions. Bauxite is processed to extract aluminum oxide, which undergoes a chemical transformation called the Bayer process. This results in alumina, a white powder, which is then subjected to electrolysis in a smelter to separate aluminum from oxygen. The aluminum is melted and cast into ingots before being further refined and rolled into thin sheets. Through a series of high-temperature rolling and cooling processes, aluminum is thinned to the desired thickness. After cold rolling and strengthening, the aluminum is cut, wound into rolls, and prepared for shipment. The final product is a durable, flexible material that can be used in a variety of applications, especially in the kitchen. The birth of aluminum foil. A brief history. Aluminum foil was invented by the American company Reynolds Wrap in 1947. Initially, it was used to wrap chocolate bars. Since then, aluminum foil has grown into a widely used material in kitchens worldwide thanks to its durability, resistance to water, and excellent thermal insulation capabilities. The shiny side of aluminum foil plays an important role in reflecting far-infrared radiation, which helps keep food warm. But before aluminum foil can end up in your kitchen drawer, it must go through a multi-step, complex process. The main raw material for aluminum is bauxite, a naturally occurring mineral that's found in abundance in the Earth's crust. Here's how it's turned into the versatile foil you use every day. Extracting bauxite. The production of aluminum foil begins with obtaining the raw material. Bauxite, the primary ore from which aluminum is extracted. Bauxite is abundantly found in the Earth's crust, primarily in tropical regions. Countries like Australia, Brazil, and Guinea are some of the world's largest producers of this vital mineral. Bauxite is typically harvested through open-pit mining, where large quantities of earth are excavated to access the mineral. Once collected, the bauxite is transported to refineries where it undergoes initial processing. At the refinery, the bauxite is crushed into smaller particles to make it easier to process. The next step is purifying the crushed bauxite to extract aluminum oxide, also known as alumina. This is done by mixing the bauxite with a caustic soda solution under high pressure. The aluminum oxide is then separated from the impurities, which are referred to as red mud. After this process, the aluminum oxide is dried and turned into a white powder. This powder is the key material used to produce aluminum metal. The extraction of aluminum oxide from bauxite marks the beginning of the long process of converting raw materials into the versatile aluminum used in products like aluminum foil, the Bayer process. Once bauxite is mined and transported to the refinery, it undergoes the Bayer process, a chemical procedure developed in the late 19th century by Austrian chemist Carl Bayer. The Bayer process extracts aluminum oxide from the bauxite ore. Bauxite is first mixed with a hot caustic soda solution under high pressure. This dissolves the aluminum oxide in the bauxite while leaving impurities behind as a residue called red mud. Afterward, the aluminum oxide is separated, purified, and crystallized into a fine white powder called alumina. This alumina powder is a key intermediate product. It's then shipped to smelters where it will undergo electrolysis to produce pure aluminum metal. Electrolysis and smelting. The next step in producing aluminum is the electrolysis process, which takes place at an aluminum smelting facility. Here, alumina is subjected to a high-intensity electric current to break the strong bonds between aluminum and oxygen atoms. The alumina powder is placed in a molten electrolyte bath, typically made of cryolite, a sodium aluminum fluoride mineral. The process requires enormous amounts of electricity as it consumes about 10 times more energy than steel production. As electric current flows through the bath, aluminum oxide, also known as alumina, decomposes, separating the aluminum metal from the oxygen. The oxygen gas rises to the surface of the bath while the aluminum metal settles at the bottom. This method, called the Hall-Héroult process, is the standard method for extracting aluminum from alumina. The result is pure, molten aluminum, purifying and casting. Once aluminum has been separated from oxygen during the electrolysis process, it remains in a molten state, still containing some impurities. To purify the metal further, it undergoes a process known as casting. During casting, the molten aluminum is poured into large molds forming solid rectangular blocks called ingots. These ingots are typically several meters long, ranging from 4 to 5 meters, and can weigh several tons, making them quite massive and heavy. After cooling and solidifying, the ingots are removed from the molds and are ready to be transported to the next stage of production. The ingots are sent to rolling mills where they are carefully processed to form thin sheets of aluminum. This is the stage where the aluminum will be stretched and rolled, gradually becoming thinner and thinner until it reaches the desired thickness for various applications, including foil production. The ingot size and weight make it a key component in the aluminum manufacturing process, as it will eventually be transformed into products like aluminum foil, beverage cans, and other essential items. This transformation is crucial in making aluminum usable for the wide variety of products we rely on every day. Rolling and thinning aluminum. Once the aluminum has been purified and cast into large ingots, it is ready to be processed into thinner sheets. The first step in this process is to heat the aluminum ingots to a specific temperature, which makes the metal more malleable and easier to manipulate. This heating process helps reduce the risk of cracking or breaking during the rolling stages. The heated ingots are then fed into a series of rolling mills where they undergo high pressure, stretching the metal to reduce its thickness and transform it into sheets. The rolling mills work by using progressively smaller rollers, each applying more pressure to the aluminum to gradually thin out the material. The aluminum passes through multiple rolling stages, each step bringing the material closer to its final thickness. As the metal becomes thinner, the surface area increases, and it is crucial to maintain uniformity throughout the process. To prevent the aluminum from sticking to the rollers, a special coolant mixture, consisting of 95% water and 5% oil, is used. This mixture not only prevents sticking but also keeps the temperature of the material controlled during the rolling process. The result is a long, continuous sheet of aluminum, which will undergo further processing steps to achieve the desired thickness for various uses, including aluminum foil production. The rolling process is vital to ensuring that the aluminum is uniform, smooth, and thin enough to be transformed into products used in everyday life, from packaging to cooking materials. Cold rolling. After the initial stage of rolling, the aluminum sheets remain too thick for use in foil production, so they are sent to a cold rolling mill. Cold rolling is a critical step in the aluminum foil manufacturing process, as it reduces the thickness of the aluminum while enhancing its strength and uniformity. During this stage, the aluminum sheets are passed through a series of rollers, which apply significant pressure to stretch and thin the material. As the aluminum passes through these rollers, its thickness is gradually reduced and the material is elongated, making it suitable for further processing. One of the key advantages of cold rolling is that it also improves the mechanical properties of the aluminum, making it stronger and more durable. This step ensures that the aluminum foil produced is not only thin but also uniform in thickness, an important quality for foil used in food packaging. In addition to reducing the thickness, cold rolling gives the aluminum a smooth, shiny finish, which is essential for creating the glossy appearance that is often associated with high-quality aluminum foil. Throughout the cold rolling process, the temperature is carefully controlled to avoid damaging the aluminum. The rollers themselves are designed to exert precise pressure, ensuring that the aluminum sheets remain intact and do not tear or distort. The cold rolling process is performed in multiple stages, with each stage using rollers of varying sizes and configurations to progressively thin the material. At the end of this process, the aluminum sheets can be as thin as a few millimeters, making them suitable for the final stages of production. The uniformity in thickness and the smooth, shiny finish achieved during cold rolling is critical for producing the high-quality aluminum foil that is widely used in a variety of industries, particularly for food packaging and preservation. Further processing and finishing. Once the aluminum has reached the desired thickness, it is time for the finishing touches. The sheets go through a final heat treatment process to make them more flexible and bendable. This process also reduces the metal's hardness, which is essential for making it easier to shape and mold into the final product. At this stage, the aluminum is often cut into smaller pieces or rolled into coils, ready for shipment to various industries. In some cases, the aluminum is printed with special patterns or coated with protective layers to prevent oxidation. Rolling into foil. The final step in aluminum foil production is the rolling process, where large, thick aluminum sheets are further thinned into much thinner sheets, often measured in microns, thousandths of a millimeter. These sheets can be made as thin as 0.000165 inches, 0.0042 millimeters, depending on the intended use. During this process, the aluminum is carefully rolled through a series of mills that apply high pressure, gradually reducing the thickness of the metal. Once the aluminum sheets reach the desired thickness, they are wound into large spools or rolls. These large rolls of aluminum foil are then transported to cutting stations, where they are sliced into smaller rolls suitable for consumer use. The final foil rolls are typically packaged in protective materials to prevent contamination during handling and shipping. The packaging serves not only to maintain the cleanliness and quality of the foil, but also to keep it from getting damaged. This ensures that when the foil reaches consumers, it is in perfect condition and ready for use in kitchens, packaging, or industrial applications. The precise rolling process and packaging methods are crucial to maintaining the foil's integrity and ensuring its widespread use in various industries. Packaging and distribution. Once the aluminum foil has been processed, it is ready for shipment. The foil is usually packaged in rolls of varying sizes to meet consumer demand. The rolls are packaged in protective wrappers, often with perforations, to make it easier to tear off pieces when used in the kitchen. Aluminum foil is sold through various channels, including supermarkets, kitchen supply stores, and online retailers. Because aluminum foil is lightweight and durable, it is easily transported to destinations all over the world. It plays a significant role in both home and industrial settings, especially for wrapping and preserving food. Recycling. Aluminum's enduring value. Aluminum foil is one of the most recyclable materials available. After it's used, aluminum foil can be collected and recycled, conserving natural resources and reducing energy consumption. The recycling process involves melting down the used aluminum, which can then be reused in various applications, including the production of new foil. Recycling aluminum takes only about 5% of the energy required to produce new aluminum, making it an environmentally friendly material. This is one of the reasons why aluminum is considered a sustainable material for many industries. In conclusion, the journey from raw bauxite to the shiny, thin sheets of aluminum foil in your kitchen is a complex process that involves multiple stages of extraction, chemical processing, smelting, rolling, and finishing. Thanks to advances in technology and energy management, aluminum foil has become one of the most widely used materials for a variety of purposes, from food preservation to industrial applications. And there you have it. From the raw bauxite to the delicate sheets of aluminum foil in your kitchen, we've covered every step in the fascinating process. It's amazing to think about how a simple material like aluminum foil goes through such a complex transformation to become the versatile tool we rely on for cooking, packaging, and countless other uses. Next time you unwrap a roll of aluminum foil, you'll have a deeper appreciation for the incredible journey it's been on. If you enjoyed this deep dive, don't forget to like, share, and subscribe for more insights into the world of everyday materials. Have any questions or thoughts? Drop them in the comments below. Thanks for watching.